Our final example is going to look at a story problem that contains an inequality. Keisha is planning a baby shower for her sister. The restaurant charges $350 for the first 20 people, plus $14 additional dollars for each additional guest. How many people could attend the baby shower if Keisha can spend at most $650? So looking through our steps, we've read the problem carefully. Now we need to find our question. Our question is, how many people can Keisha have attend the party? So we're going to define our variable that x equals the number of people who are going to attend this party. Now we need to look for extra information that we can get rid of. The fact that this is a baby shower planned by Keisha, taking place at a restaurant, none of that is terribly helpful. What we do need to know is that $350 pays for the first 20 people. And then each of the people after that first 20 is another $14 for the additional guests. And then our final piece of information, which I kind of scribbled over here with my fat marker, is that the most that Keisha can spend is $650. So this at most is how I know that this problem is going to be an inequality. Because Keisha doesn't have to spend the full $650, she just can't spend any more than $650. So we want the x that we use to cause our equation to either be equal to or less than $650. So that's how I know that we're going to be using an inequality here. Hope you can read that. That the total for our equation must be less than or equal to 650. So now let's start looking for how to translate this into an equation. Well, we know that Keisha is going to have to spend $350 right off the bat. Then she's also going, she's going to be spending an additional $14 for each of the people that she invites that are over 20. So this part's a little tricky. The total number of people that she's inviting, she's not paying 14 for each of those, she's paying 14 for each of those that exceeds 20. So of all the people attending the party, we're going to subtract the first 20 guests because they're already covered over here in this 350, and what we want to multiply 14 by is the number of people coming to the party that exceed 20. And then our last piece is to insert this inequality. This total, whatever it comes up to, has to either equal or be less than $650. Solving the inequality will look just like it has in previous problems. So 350 plus 14x minus 280 needs to be less than or equal to 650. When we combine our like terms on this side, we'll get 70 plus 14x is less than or equal to 650. Then subtracting 70 from each side, we'll end up with 14x is less than or equal to 580. And then our final step is to divide by 14. And I am, now that we have proven we know how to do division, going to pull out a calculator to do that long division. It comes out to be 41.43 and some more change. So somewhere around 43 people. So the x, I'm sorry, not 43 people, 41 people. The x needs to be a number that's either smaller or equal to 41.43. Well, since we can't invite 43 hundredths of a person, we can only invite a whole number of people, our answer to this question is going to be up to 41 people. can attend. So going back to check this answer in our original story, the restaurant charges $350 for the first 20 people. So if we invite all 41 of our people, we're going to have an additional $14 to pay for those other 21 people. So entering 14 times 21 into my calculator, I get 294. And when I add the $350 that I already paid for the original guests, that gives me a total of $644. And since Keisha's budget for this was $650, we will actually have $6 left over in Keisha's budget.